in this method. Oh, sorry. Okay. What am I saying with that? I'm saying this. When you establish the augmented matrix, the steps must be this: 1 and the corresponding zeros. You cannot deviate from this step, from this sequence ever. You're not going to get the answer. So 1, and then we fabricate the corresponding zeros by multiplying and adding. 1 in the middle of the second column, of course, second row, and then immediately the corresponding zeros. Finally, 1 in the last row, and then immediately the corresponding zeros. There is no other way, there is no other sequence. You cannot go backwards, meaning once you are done this, you cannot destroy it. This is carved in stone. When you finish this column, you can never go back and destroy this. In other words, you have to move on and get the 1 and the zeros, and then the 1 and the zeros. This must be the sequence at all times. Even if you say, oh, I think I can do, no, you can't change. You have to stick with the plan. Okay, so this is what I need to do. Now, since this is priority number 1, from the very beginning, I'm going to swap these two because I want a 1 here. So I'm going to consider this as being first equation. The order is not important. The system is the same. Even if I rearrange them in any order, the solution will be the same. And I'm going to check at the end. But I'm going to put this number 1. I'm going to put this number 2. I'm going to put this number 3. So the augmented matrix now is 1, 5, -1, -4. 0, 3, -1, -1, -3, 6, 2, 11. And so far, I'm happy. These are done. I need to get a 0 here. In order to get a 0 here, I have to use this row, multiply it by 3, and add it here so I can get the 0 right here. So I'm going to make myself a note so I don't forget what I'm doing. I am multiplying row 1 by 3, and I'm adding the result to row 3. This is row 1, this is row 2, this is row 3. Why am I doing this? Because I am in this step. So this is done. This is done. I'm here now. So I always copy the row that I multiply. In this case, I will also copy the second row because I'm not going to do anything to it because I already have what I need. So 1, 5, -1, -4, 0, 3, -1, -1. 1 times 3 minus 3. 5 times 3 is 15. 15 plus 6 is 21. -1 times 3 is -3. Plus 2 is -1. -4 times 3 is -12. Plus 11 is -1. Any questions? Any questions so far in this step?
No, no questions.
Okay. The next step must be here. So I finish with this row, I finish with this column, and now I'm here. If I don't get a 1 here, I will not be able to get the corresponding zeros. This number will help me get the corresponding zeros because I will multiply this row by whatever and add it here. I will multiply this row by whatever and add it here to eliminate and get the 0 here and the 0 here. Because if you remember, once I have just ones and everything else zeros, I will say this is X, this is Y, and this is Z. That's the whole purpose of getting 1 on the diagonal and everything else 0. X will be this number, Y will be this number, Z will be this number. Okay. Now, I was just looking to make sure, did I copy everything correctly? I'll tell you in a minute why I'm checking. So -3, 6, 2, and 11, and 1, 5, -1, -4, correct, and 3, -1, and -1. Yes, it appears that I have everything correctly. The reason why I checked is because in order to get a 1 here, now I cannot swap. I'm done swapping. I can never swap equations right now. Why? Because if I swap equations or rows, I destroy the first column, which is not possible. This one is carved in stone now. So you could possibly just change these two or swap these two, but not the first one. So that's why I'm saying we can never go back and destroy this. I have to have 1, 0, 0. This is done. We're moving forward. Now, what is the difficulty with this problem? Is because in order to get a 1 here, I would have to divide this row by 3, which is fine, 1, but I will have a fraction here as -1/3, and another fraction here is -1/3. I don't know the answer. We just picked the problem. So that's why I thought that maybe it would be a little bit nicer, and that's why I wanted to check my calculations one more time. So that's indeed 15 plus 6, indeed 21, and -3, that's it, -12, -1, that's it. So now I have to move on. And the only option I have is to divide row 2 by 3. It's the only way I can get a 1 here. So let's continue. I copy the first row and the third row. I cannot touch those. And of course, this column is fixed, carved in stone. And now when I divide row 3 by 3, this divided by 3, this divided by 3, and this divided by 3. Because of fractions, it may get hairy. Okay? So, what have I accomplished? I accomplished so far the first column, and I also have the 1 where I need it. Good. Of course, at this point, I have to use row 2 multiplied by 5. I'm sorry, I meant -5. Multiplied by -5 and add it to row 1. And yes, I'm using row 2 again, multiplied by -21 and add it to row 3. Let's see if this is clear. Is this step clear so far? I haven't done it yet, but is it clear what we just did?
Yeah.
Okay. Good. I need to copy the row that I am using. Which row am I using? 0, 1, -1/3, and -1/3. And this is carved in stone. I won't even look here. One times -5 plus 5. Now this is getting, as I said, a little cumbersome. -1/3 times -5 is 5/3. 5/3 minus 1. is 2/3. Negative 1/3 times negative 5, again, is 5/3. Minus 4. 5 minus 12, negative 7. Negative 7/3. 1 times negative 21 plus 21, 0. Negative 1/3 times negative 21 is positive 7. Positive 7 minus 1, 6. Again, positive 7 minus 1, 6. I accomplished a lot. 2 columns are done. This part is easy. I need to obtain a 1 here. How will I obtain a 1 here? Notice that I cannot write equal. Between this matrix and this matrix, I cannot write the equal symbol. I can only write an arrow. So I'll write an arrow. How do I get a 1 here?
By dividing by 6?
Exactly. So I am dividing row 3 by 6. You can copy the first columns. You cannot touch them anymore. When I divide both here by 6, now I have to copy the rest. 2/3, negative 1/3, negative 7/3, and negative 1/3. Final step. Of course, I have to use now row 3. Multiply it by negative 2/3 and add it to row 1. Also row 3, multiply it by 1/3 and add it to row 2. So I can eliminate both and get 0, 0, and 0. Can anyone look at this and say, I know we already have one of the 3 variables. Which one do we have and how much is it? Anyone? Which variable we already have and how much is it from X, Y, and Z?
Z, and it's just 1.
It's it. That's it. Exactly. We are working actually on X and Y now. Very good. Yes, it's a cumbersome method. It is. And especially when we get fractions. But it's not a difficult concept to understand. Okay, so of course I have to copy what I accomplished, and I'm only working on the 3rd column on this and this. Don't even look at the rest. This is done. It's finished. 1 times negative 2/3 plus 2/3. 1. Sorry, I didn't finish. Sorry. 1 times negative 2/3 plus 2/3. 1 times negative 2/3 minus 7/3. Negative 2/3 minus 7/3 is negative 9/3. Negative 3. 1 times 1/3 minus 1/3. 0. 1 times 1/3 minus 1/3. 0. We claim, we don't know, very easy to make a mistake with these systems in Gauss-Jordan. We claim negative 3, 0, and 1. X, Y, and Z. Is it true? I have no clue. And I'm not just saying that. I have no clue. I have to go back and check. And I'm checking negative 3, 0, 1. Negative 3, 0, 1. Negative 3, 0, 1. A negative 3, 0, 1. This is fine. Negative 3 minus 1. This is fine. This is 9 plus 2. Yes. It was a long problem, especially because of the fractions. I'll make sure you don't have to worry about fractions because I don't want you to spend time in finding your mistakes. I just want the idea and the concept. If you understand the concept, 1 0 0 1 0 0 1 0 0, you will not make a mistake.